Well, hi, good morning, and welcome to my shop. So I'm going to be focused on something that might be causing the popping in here, which a birdie flew into my email last night and suggested something to me, which we'll be looking at in a minute. But first I want to thank a viewer whose name I won't say here, who apparently hunted high and low and in all the back rooms of the internet and actually found a schematic for this guy on somebody's Facebook page. So I just can't thank that person enough, because I had accepted at this point I'd be doing this without a schematic. So I haven't looked at it closely. Pretty sure it's the right one though. We'll get that out eventually and take a look at it, of course. And another thing I've learned about this amplifier, and thank you to the same person pointing out that, of course, this amplifier is among the last, say, domestic tube amplifiers of some quality that were produced. I don't think there were too many more produced after this. And it contains some of the latest thinking and circuitry, if you like, related to this kind of amplifier. And that includes using techniques to make the amplifier extremely linear. It has a lot to do with the way the screen voltages are controlled in the output tubes and that. I'm not going to go into detail about it. I don't know it in detail. But I know there's something going on here in terms of operation of these tubes to achieve a excellent output. So it's just another element saying this is a great amplifier, provided it's doing what it's supposed to do. So now, and what am I going to do? So first I'm going to make sure that everything's turned off. In fact, let's pull this out here. That's a visible point of isolation, because I'm going to be fooling around in here right where the power comes in. So what I've been told, and I did not know this, and I don't know how I would ever have known this, is that the diodes here, the top hat diodes, which I'm sure are original and therefore the same age of the whole thing, these have a characteristic failure that can result in exactly the kind of effect we're hearing in the popping in this amplifier. So I'm just going to replace these. These are cheap. It's no big deal to replace them. I got lots of replacements for them. So I'm going to do that. The result is, well, we'll find out. If we don't hear the popping again, then we can be reassured it's these. I don't think I'm going to bother trying to test them out and try to hook up equipment, run the amp, see the pop. I'm not going to do any of that. I'm just going to go ahead and change them, and we'll carry on. If we never hear the popping again, then we can be 99 and 44, 100% sure it was these guys. So that's my goal today. But like I said, I'm trying to keep my eye on the testimony that's going on today. So I got to hunt down suitable replacements for these, and these appear in the schematic. Hey, maybe we'll take a peek at the schematic right now. Okay, so here's the first section of what are 3 pages covering the schematic here, and this very much looks like a photograph of the paper schematic. So now I looked in the cabinet for a hidden schematic. I looked, sometimes there's a pocket, an envelope or something stapled up on the side of the cabinet somewhere. I couldn't find one, but obviously there was one for this individual who managed to photograph it. So thank you very much once again, because this is going to save my bacon on this for sure. So let's look at the diodes. They're right there to be seen. Whoops, to be seen right here. A little 1K capacitor across them, which I see is there. 310 volts. So there's no indication of how much current's flowing through here, but it's going to be substantial. But the diodes normally can carry quite a bit of current without much difficulty. There's the filters, some more filtering here. Okay, so exactly what they're up to here, I'm not sure. But something's going on with the power supply. Not to worry about that, I just need to worry about this right now. 93L5. So I think I'm going to dash 2. 93L5-2. Let's see if we can find something about that on the internet. 93L5. So this is an equivalent. NTE number is given here, 117. 600 volt peak reverse voltage, 1 amp. That's typical. That's quite typical. So the main thing I wanted to find out is this 1 amp flow through here. So here's a table in the Wikipedia with a list of diodes and their simple ratings here. So I have all these 4000 series diodes and hundreds, maybe 1,000 more, all kinds of older ones, but I have these new ones here, so I'm going to pick a new one from the list here. In this particular application, it looks like 1 amp is fine, so these 1N4 ones would be fine, and I'm just going to pick the top guy on the list here with a voltage it can tolerate of 1,000 volts. Because the capacitor across the diode is rated for 1,000 volts, that might be a good idea. So 1N4007 is what I want to replace them with. 1N4007. Okay, so I'll just compare these because they're so much smaller. They'll fit nicely in there though. It's an easy replacement here. Yeah, no problem at all. Okay, let's solder these two guys in. Yeah, I'm very lucky. If this is the cause of the problem, I'm very lucky that somebody pointed it out to me, because I would never have been suspicious of these diodes. If on the other hand the unit keeps popping, well, it's just as well probably to get rid of these original. The original diodes. The squeeze down on that. Okay, there they go. I really hope that stops the popping problem in here, because if this isn't the cause, it's going to be a tough battle for me to figure it out. That's, I think, the case. Great. Now, I think that's just going to sit there for a while. I'll get back at it in a bit. Okay, so let's take a look at the schematic here and just try to extract a little more knowledge about this guy. And this is kind of interesting here. These are the speakers here, and these are the jacks that are on the back of the amplifier. So we can see what I kind of figured out by looking at it is absolutely true. We have one channel coming here and the other channel coming here. We just take this one. You can see sound going down through here is forced through a choke, so the highs are going to disappear. This will be the woofer. And down here they're forced through a capacitor, so the lows will disappear, and this will be the tweeter. And then we have these two, which right on here it says extension jacks, and sure enough on the unit that I have, there's 4 plugs plugged in these terminals with nothing plugged in here. So that kind of raises an interesting question then, since this is restricting some of the sound and this is restricting some of the sound, is there anywhere where this, the core of the sound makes it through, so to speak? So I guess these are sized in a very particular way, related to what's going on in the cabinet. This is the beauty of consoles, by the way. The engineers have their day with these things. They know there's problems with the speakers and speaker response and all that kind of stuff, and they can fiddle around with the design here and all kinds of aspects to compensate all over the place for problems all over the place and get an excellent result out of these consoles. So that's why I like them so much. So what have they done here? So okay, so this has got to be the bass speaker, and then you see this plug goes to 2 speakers, and there's another capacitor involved, 2 microfarads, 15 volts. So this must be in the cabinet. I haven't seen this capacitor. So here is another crossover. So they have a crossover basically sending the mid-range and treble out here, and then the mid-range is shot to this speaker and treble is reserved for this little one. In fact, look at the symbols here: big, medium, and small. So that's what's going on with the speakers in here. So this is excellent, assuming all this is working properly, and the engineers knew what they were doing, and I'm sure they did. This would probably be an excellent sounding stereo console. They all kind of are, especially if you see 3 speakers. Somebody's put money into this thing, so to speak. So there's another shot. This is just the output. You might as well just dwell on this for a minute. We'll look at this channel here. So sure enough, you have the 2 6BQ5s operating in push-pull through this transformer of many input wires. Now we can see why there's 5 input wires. It has to do with this important feature here, which is the connection into the screen. And this is where this amplifier becomes known as an ultra-linear amplifier, because of careful attention paid to this resistor right here and the overall operation of the tube to provide a ultra-linear output. Great. Now, so push-pull requires the signal and an inverted version of the signal to be provided to these 2 tubes, and that's taking place in this guy back here, which I see is a 6FQ7 or a 6CG7. I'll bet you I can find that on my tester. 6CG7. So we'll be able to test these tubes, but I'm pretty sure they're good. They're fine. So the basic job of these 2 tubes is to receive the signal here from earlier on in the receiver, or maybe from the record player, and then through these 2 tubes produce 2 signals, one 180 degrees out of phase with the other. Now you can actually see that the grid of this one is connected to the plate of that one. This is the same tube, right? Just 2 halves of the same tube. So the result of that is you get let's call it a positive signal and a negative signal. That's not quite the right words to use. One comes out of here, inverted, and the other one's coming through here. In fact, you could kind of whoops, coming through. Oh, okay, I take it back. So I take what I just said back. So if we look at this tube, just look at this tube. You see a 68K resistor here and a 68K resistor here. So as this grid goes up and down in potential, the I hate to call it this, the tube resistance, I'll call it that though, is going up and down. So it's like 3 resistors in a row here. And if you think about this long enough, as this resistance goes up and down, bigger and smaller, it causes a variation in the voltage here and here, which is actually 180 degrees out of phase. Like a seesaw on this thing. This is the fulcrum and the seesaw. And so one of these tubes is conducting on one half of the signal cycle, and the other one is conducting on the other half. That's kind of what's going on here. So this is not really an inverter. So this first stage is just amplification, and maybe, well, I don't know. The interesting thing here is, look, there's no capacitor in here. How does that work? Hook the grid right to the plate? Is there something missing on the schematic? So what is this line? This has to be a high voltage line here. 34 volts, it says right there. Plus 34 volts onto the grid. Here's the same thing up above here, same thing. Okay, so I don't quite comprehend what the story is with this, but again, I think what we're seeing is pretty advanced design here, achieving a high quality output with the least amount of parts, of course. That's always the objective here. We've got a 1K resistor here biasing this tube. Very interesting. Maybe there's something very special about these tubes. I don't know, but that's a weird thing to me. I think it just exposes a gap in my knowledge. I think that's really what's happening here. Great. Well, that's kind of a overall look at the whole, nearly the whole schematic. Let's get back to this. So there's a hum in this receiver, a low hum, not very strong. And I'm guessing it's coming from one or all of these not doing their job 100%. Could it be from bad diodes here? I don't know the answer to that. I know in a tube set, if the tube rectifier starts wearing out, it starts developing a higher and higher voltage drop across the tube, and that can result in a hum showing up in the radio. I wonder if this could be the same thing here. I don't really know. So, you know, what I need to do is augment or replace these guys. Replacing being pretty, you know, considering it's not got a lot of hum, I'm not inclined to replace these, but maybe I can augment them, add in a little more. These are hundreds, they're pretty big already. These are only 50s. I can easily add in more here. See if that doesn't knock out the hum. Okay, I think we're ready to apply some power to this. Got my scope running over yonder, up yonder. Just to practice, I'm going to clip this onto the chassis. And then going to touch here, and here, 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 and here. And we're going to see what we see. The objective, right now the scope is switched on DC. So there's about 300 volts here. 300 volts, yeah. Let's put this way up. 5 volts per division. I'm going to stick 300 volts on there. That's not going to work out so well. It's going to go right off the screen. What we'll do is we'll just, you know what, we'll do it on AC. So I have the input set to AC on the scope. When I first attach the probe, the scope is going to fly off, but then as the capacitor balances out inside the scope, it will come back onto the screen. And then we'll be able to read how much ripple is there, and then we got to make a judgment as to whether that's too much ripple or not, which is a little bit on the tricky side. Okay, and we're on 5 volts per division. Just put it right in the middle there. Okay, I'm going to start up the amplifier. It's the first time it's been started up after having diodes in the power supply, so chance of a mistake is high. And what we could get is bright, dim bulbs or smoke coming out of here. Either way. Either way might be exciting. Okay, let me just hide behind the... Here we go. Absolutely normal. I'll wait for those lights to come back a little bit, the dim bulbs. That'll tell me the tubes have warmed up. The tubes are conducting. Waiting, waiting, waiting. There they come. There they come. So what's happening now is the tubes are beginning to conduct. Ooh, what's that? What was that? What was that? That was not me. Not me. Well, I'm not sure what to make of that funny sound. Now as for hum level, uh-oh. I think it's still just warming up. It could take a long time when you restrict the power. So I think now we're hearing noise coming through. Let's see if it's from the input wires I have soldered here. Yes. So I'm injecting a little bit of noise just from the lead wire I soldered in here. There is a hum, but it's very low. It really might not even be enough to worry about, frankly. Okay, let's do the study here. We'll leave it on dim bulbs. The operating voltage, oh, it's only 88. No wonder. Let's give it the full shot here. You know what I really should do? I happen to have my thermal viewer sitting right here. Let's get this guy going. Let's just see if anything's cooking up. This is really too sensitive here. Just 1 second while I just make an adjustment. A little less. Okay, now we'll look inside. So this is a little hard to get on camera. Let me see if I can get this to come up on the camera here. That's a little better, isn't it? I'm gonna have to figure out how to do this nicely. So you see, there's something a little warm in there. Those red things. Let's see if we can figure out where those are. So what we're seeing are the tube bases, I'm pretty sure, and maybe these high wattage resistors here. Yeah, I have this just too sensitive. Let me desensitize it some more. Now for it to display red, the temperature has to be 40. So we certainly have a hot spot right in there. It's being duplicated. It's the resistor. So when I look at this, and I'm sorry this really isn't coming across on camera very well. So there's an angular thing there that's bright red. The white dot is right on it. And then you see the spot, a spot, and a spot. Okay, so the angular thing is this resistor here. And the spot, and the spot, and the spot are the tube sockets. Nothing out of the ordinary here. Nothing at all out of the ordinary. Nothing extremely hot. It's a very wide angle lens on this. So okay, everything's fine. We're golden. We'll go full power now. The hum should get louder. Now again, the hum is either power supply hum, I'm sure you can hear it now, or it's being caused by this wire I put on. Let me try the wire. So I hear the noise, the kind of a sparkly, hissy noise come up a little bit, just like it did last time, but the hum didn't change. So I'm pretty sure the hum we're hearing is coming right out of the amplifier. Now we'll go back to looking on the scope here. See what kind of stuff we can find on the top of these capacitors. So here's the first one. So that's a pretty good hum signal there. We're on 5 volts per division, so I think that's a volt or two. Now we're going to go a little further in. Here. That looks pretty clean, doesn't it? And we'll take a look here. And that also looks very clean. Appeared to be nothing there. And I don't think touching that. Yeah, so there's something there. So this capacitor is a single capacitor. This one's a triple. this forms one part of the two back-to-back capacitors. The other part is right there. And you can see hum on all three of these pins. Whoops. Not that one. Yeah, all three of these. Associated with the first filter stage. What was that? Uh-oh. Something a little loose. Okay. Son of a gun, what is that? I don't like that one bit. Where's my stick? Quickly, revert to the stick. I need the official magic stick. Oh my gosh, what's going on? Okay, it's not the parts I just put in. I'm tapping the tubes. Wow, there's just a lot of heat flowing up from all those tubes in the back. So I think the tube is a little, the tube in this position is not in the socket correctly. No, it's right in there. Okay, power back on. What that was. Right, so to deal with the hum now, I have to decide which one of these capacitors I think needs to be augmented by additional parallel capacitance. So let's look again at the output on so there's two capacitors that are back to back, and negative to positive, in series would be the right word. And the other ones are typical parallel type arrangement. Those ones seem to have absolutely no hum. Got my scope. Okay, that's a really sensitive setting now, and you can see a little bit of wiggle in that line. Uh-oh. Uh-oh. Hey, don't say uh-oh, we're in a good position. So this is the problem. Starting, it wasn't those. Abandoned ship. On to another problem. Quickly, find my this isn't gonna help. Ah! Let's let it continue. Let's not let it continue. So clearly this is a heat introduced problem. And if I get a voltmeter on the right terminal, I'm gonna see where it is. For crying out loud, where's my voltmeter? Right at the time when I need it. Like an emergency. Okay, so here's what I've got set up here. I've got this meter ready to measure general B+ at the output of the power supply, which can be found on this terminal just beyond this big 15-watt resistor. So this is what's going into the rest of the radio and going out to the receiver too. So that's what that'll be watching. I expect this to come up to 300 volts or so and sit there. Then I'm going to use this meter to poke around. The ground connection from that meter is right here on the chassis. And you can see this stupidly long wire I put in to feed input signals in. I've grounded the end of that wire. So the input to the amp is grounded, but on this long wire. I don't think it's going to cause a problem. So what I'm hoping to do is turn this guy on, poke around a bit and just make sure I know where to take readings and things are all adding up while we wait for the pop to come back. As soon as the pop comes back, my plan, you know what my plan would be? Go right up onto these output tubes and plate by plate by plate by plate and watch each one of them, because I'm still concerned that this problem is coming from the output tubes. It's very likely the situation. So I need to know which one of these terminals is the plate. Plate would be the best place to look, I think. Let me just take a peek here quickly at the schematic. Pin number 7. Pin number 7 is the plate. So I'm going to count these. The set is off. 1, 2, 3, 4, 5, 6, 7. The blue wire. Blue wire. 9, 8, 7. Brown wire. Blue wire. Brown wire. So, okay, very easy to pick it off with the meter. Test. I'm practicing. Test. Test. So easy for my tester probe to slide off and short onto the next terminal. So I got to be a little careful doing this, because there should be a pretty high voltage sitting here. Is my arm in the way? I don't think so. No, not at all. Okay, so we'll switch on, fool around, make sure everything's working, hope the pop comes back. There we go. We can watch the B+ meter. It's got to go a little higher than that. So there was a little pop in here just now. Well, I expect this to be 300. Something's wrong here. So we're on the 500 scale. I'm expecting the meter to rise up to the 300 mark here. Yeah. Oh, well, I got it on 1,000. That's 300. Okay. Really? That's how this meter's working? That didn't seem right, does it? Oh my gosh. My meter needs cleaning. 218. How's that add up? Oh, I've never had that. Of course, I don't normally have this meter on 1,000. So this is reading just about exactly 218. So we got matching voltages here. Just for fun, and to increase the pace at which we're going to get to the pop, I'm going to give it full. Oh, we're here. We're here. We're in. Oh. What is it? What is it? What is it? Okay, do what you said you were going to do. Oh my gosh. Okay, it's popping. I can see the meter pop there. Popping. It's going to pop on all of them. They're all going to show up. You know what? This is up, up, up. Ooh, look at that. Is that me doing that? Don't get excited now, you get a shock. That's me doing it. Down. Down on this case, and what about this one over here? Up, up, up. This is the only one going down. Okay. Pull the tube out. I can't do it. I'm just scared to do it with the power on. One tube out. Power back on. It's one of the Phillips. $268. Oh, son of a gun. Okay, so that got even wilder, didn't it? So we know we're in the zone, but I don't think it's the tube. I don't want it to be the tube. I want it to be something else. This darn tube is hot. Let's put it back in. Ooh. Hold on to the hot tube. Not so hot anymore. So, unfortunately, again, one of the strong possibilities here is it's this output transformer right here that's doing this. Don't want that to be the case. It shouldn't be the case. It could be almost any one of these components here, especially if any one of them is getting a little warm. Okay, so I think the approach I want to take now is just to look at this and ask myself, what am I seeing here that's most likely to be causing popping around this tube? And the answer is really quickly this big capacitor here. There's 4 of them in here. I looked at the schematic. I believe they're involved with the grid circuit to the tube. So I can't really say for sure if this opened or shorted what the end result might be. But they sure look suspicious too. So let's take a closer look at them and see what we can see. Starting with the one that's right on the capacitor in question. Let me just improve the lighting here. And it's a perfect 0.047. So these are definitely the capacitors I'm looking at on the schematic. 0.05s. These are 0.05s. The part that's got my attention is, you know, you can see the leads coming out of it down below. What's going on the top? You can see some, it looks like exposed metal there. Let me get up real close here. Just 1 second. Let me just fix my camera here. Just hang on here. We'll get right in as close to it as we can. Vinyl 10. Okay. Now, let me just get out of the way of the light. So look at the top. Something's coming out of it. So look at the next one. Well, it's even worse. The other thing is, I noticed these right off the bat. They look greasy. The outside of them looks greasy. That suggests to me that something is breaking down in them. Erie. I wonder if that's Erie, Pennsylvania. Looks like this bump. This bump must be where a lead comes over the top of it or something. Something like that. Some kind of structure inside. And that's broken free in this case. How about this one here? It also shows degradation in those same kind of areas here. Including a cobweb hanging off of it. I think I've seen enough. I'm going to replace all 4 of these. The resistor's caught my attention there. Right under the orange band, it almost looks like a crack, but I don't think so. I don't get too involved with how everything looks. But let's get rid of all 4 of those capacitors. Once that's done, then there's no question that they are the cause or not the cause. They're out of the picture. So I'm going to do all 4 of these, and we'll put in a 0.05, and voila. Well, we'll see if it's voila. Okay, so got the 4 capacitors out. Hey, you know what we're going to do? We're going to test those old capacitors. Boy, I almost forgot about doing that. Let's check them out. So I've got them sitting here in the same order they were inside the amp. So this would be the one that was potentially causing the problem, and these are the others. So we'll start with the others. Now what I'm going to do here is I'm going to apply a high voltage to the capacitor. Nothing out of its range, if you like. And the idea is no electricity should go through the capacitor. the results of what I'm doing are going to be shown on this eye here. Let me just change lighting. See if we can get this to show up a little better. There we are. That's good. So you can see the magic eye. And as I perform the test, the results are indicated with the eye. So clipped in here. First test is going to be at 50 volts. Expect the eye to pop right open. Okay, try it at 150. Try it at 250. So that's a perfectly good test. Just give it a moment, and I'll measure the value of the capacitor. Should just keep that there for a moment longer. So our expectation, this is a 0.05, basically 0.05 should show up on this scale. So I'll just swing the dial, and let's watch for when the eye pops open. There it is there. Pops open wide. On the scale, there's 0.05. This is actually a 0.047. That's measuring is a 0.039 on my... No, don't read that scale. Yeah. Very close anyway. Certainly nothing wrong with this capacitor. That would be the... Now, this problem the popping in the receiver doesn't start right away. It takes a while, and then the popping starts. So that's not terribly characteristic of a capacitor. Might as well test it for its size here first. The very same result, and I can't imagine that there's any kind of problem with this. Good. 350. Yeah. These are highly reliable capacitors. I wouldn't normally change these. These looked a little greasy to me, and don't really know why greasiness would be an issue, but also one we expect to be good. Okay, we'll try it on the 150 volt setting. Watch the eye. No surprise. Okay, and I've charged it up a bit, and you have to just give it a moment to discharge. Okay, that should be enough. And it's exactly the same as the other. Oh, this isn't opening up quite as much. Sometimes the indication of a little bit of a leak in there, even though the first test showed no leak. Now here's the guy we think might be causing the problem. Measure the size. A little bit of unusual effects in the eye there, but size is reading exactly the same. 150 volts. Yeah, so what's going to happen here? Can I heat this up and bring on the fault? It's not very likely. Don't think I even want to try. We're going to turn on the set and see if the popping's gone. Maybe it won't be. Maybe I didn't hit the mark here. Okay, I've got the voltmeters ready. So that's going to read the B+, and that's going to read whatever it is I touch. Okay, dim bulbs, normal operation. Isn't this a lot higher? So we'll double check. I think it's a lot higher. Oh, it's coming down now, of course. So yeah, I got on there too quick. So what's happening now is the tubes are coming to life, drawing power out of the power supply and drawing down its voltage. down to, yeah, back to where it was, roughly. Good. Clear, distinct hum coming out of the speakers. Cleared that up. No particular poppiness. Let's measure a few voltages here while we're waiting for action. So this is a plate here. Now I can't look over at the meter. I don't dare support my hand on the chassis while I'm doing this. Okay, so it was about 220. Just about exactly the same as that. Couldn't be a red wire going right to that pin. Let's try this guy. Exactly the same. This guy. Exactly the same. It might be just a touch lower. Yeah, likewise here. Slight difference between the pairs, but they have no significance. Now, the interesting one now is the screen voltage. So I think that was the plate I just did. I'm not even sure of that. Let's just poke around and see what happens when we hit another high voltage terminal here. Great. So this is the screen, and this is the absolutely critical resistor here. It's a brown, black, brown, and I'm trying to remember what I saw on the schematic. It could very well be exactly that. So first we can measure this side of the resistor and compare all across. Okay, so that's two. What I can see, just and just it's 210. It's 220. That's 220 on the meter. 220. 220. Looks like the entire B plus is sitting here. 220. Now, if there's any variation in current between flowing through these resistors, then I'm going to get a different reading on the other side of the resistor. Oh, there's no current flowing. So that's 220. 220. 20. 220. Everything's 220. There's no current flowing in those resistors. So maybe they're not what I thought they were. Bearing in mind, anytime I could tap something that just caused a huge pop to come out of the speakers, and well, that's a little surprising. Let me just peek momentarily here at the schematic. I'm just going to look at it myself, and the screen is pin number 9 and has a 100 ohm resistor on its way back to the output transformers. 100 ohm resistor. Sometimes resistors are used like that, more like fuses. Okay, so what you're hearing is not coming from anything to do with this. It's just in the other part of my house at the moment. So ignore the sound of the radio. So this has been on now for 5, maybe 10 minutes. Not a pop. Not a pop. Let's put it up to full voltage here. I think I saw 315 written on the schematic for the B plus voltage, so 328, not bad. Hum is quite distinct. No popping. So just the fact that I took those capacitors out and tested them and didn't find a problem during the test doesn't mean that that capacitor wasn't the cause of what was happening here. It's hooked up to a post with a high wattage resistor. Actually, the high wattage was not hooked to that post. Okay, I'll take back that theory. What I was going to suggest, though, was it took a little bit of time for heat to pass to it. Maybe that's true. Before it would start popping. Maybe in a few minutes it's going to start popping again. Or maybe it was a bad solder connection I accidentally repaired during this. Or maybe I put these in wrong and it doesn't work the same way anymore. Okay, gotta stop. Leave it running for a while. Okay, let's take a look at the thermal situation in there with the thermal viewer. This is kind of awkward how I'm doing this, but hopefully I can still succeed in getting somewhere with it. Now, some of the out of focusness is the image itself on the infrared thing. It's not very sharp, of course. A little bit of might be focus on the camera here. Okay, so what are we looking at? So I have the good fortune of being able to look past that right at the radio. Look at that. Socket, socket, resistor, socket. Some of the heat has flowed upwards, I think, and is heating the chassis up in here. Okay, I'll move over to the other tubes here. Again, I apologize for how awkward this looks, but so that's all four of them there. But that's the 1, 2, 3, 4 tubes. Looks like the resistor here is a little hotter on this side. We see a tube, socket, and some heat in here. And a little bit of heat out here. Now it's not much. It's not all that much. So what exactly are we looking at there? Let me just switch cameras. It's much better. So this resistor seems to be a little bit hotter than that one. There's a little bit of heat in some of the resistors up in here, but it's not much. I think it's good. What's not good is the hum. We should let's just take a look down here. Just hang on 1 second. Sorry, I forgot to look. Nothing hot down there at all. A little bit of red you saw is all up in here. Great. Excellent. The hum. Okay, the hum is next.